All right, it's recording. Let's go. Exercise 18A, tangents and normal lines. Let's do the first example together. Okay, and then I'm going to show you how to do it on a CAS as well, so you can check your answers. There are short ways of doing it on your CAS. We've got Jules and we've got Ollie. Yes, saved. Okay. What's the question? You've got a tangent. Listening. You got a tangent to the curve. They tell you the curve. They tell you this is your graph. Okay? They are saying there is a straight line equation that touches this curve, at x equals 1. Okay, so if you picture it, you can think of it as this is your axis. I'm just going to draw a random axis just so you can sort of picture it. And then we don't know what the curve is. Technically, it's an x cubed, so it's a cubic function. For all I know, it could look something like this. Okay, I don't know if that's true. Maybe it's not. But if this is your cube, this is your curve, they're saying that when x equals 1, so hypothetically x is equal to 1 here, at this point, there is a tangent line. So I'm going to draw a tangent line, just a nice straight line that touches that curve once. Okay, what they want you to do is to find the equation of the straight line that will touch that point at x equals to 1. Okay, we don't know what the y value is. But if we were to find this y value, how would I find that? Anyone have a clue? Matt? And that will allow you to find what? Very good. So then you'd find m at that point. My question is, what if I just want to know the y coordinate at the moment? Sub in 1 where? Sub x equals 1 to this. Okay, so that will give you the y value for whatever question that you need later. You may need to use that y value. So at x equals 1, we don't know what the y value is yet. So this is the y value. How do you find the y value? This is the function to find x and y. The function that Matt was describing just now was the derivative. And I needed you to understand the derivative is the gradient. Okay, so we're going to talk about it again. So here we go. This is your equation. Y equals to x cubed plus half x squared. That's the relationship between y values and x values. Then Matt said, find the derivative. So if I find the derivative, let's see how good your derivatives are. What's the derivative of x cubed? Let's go with Nathan. X cubed, derivative. Very good. We've got 3x squared plus, what is the derivative of half x squared, Lohit? Sorry? Yeah. I said, what is the derivative of half x squared?
I thought I said it right.
Yeah, I didn't hear it. I was just asking.
Okay, made me question myself.
You questioned yourself. Didn't take too much to question yourself. That's good. I can push you over. All right, so we've got 3x squared plus x. That is the derivative function. What I want you to understand is this is the relationship between the gradient and the x values. So depending on what question they're asking, if they're talking about your gradient, you use the derivative function. If they're talking about the y coordinates, you use the original function, because that's the y and x relationship. So that's why when I asked you before, I said, what is the y value? You should not be substituting it into this, because I see that too often. Okay, so that happens all the time. You just sub 1 into wherever you want. And often in this chapter, you get really used to finding derivative. And most students will sub 1 in here, not realizing when you sub it in, all you're figuring out is when x is 1, you're finding out the gradient. We're not trying to find that yet. Right now, I'm just asking what is the y value. Okay, so if you want to know what the y value is, well, when x is 1, I'm going to figure out what y is. So here we go. Let's do it. I'm going to sub 1 in. So I'm going to write on the side here, sub x equals 1. So therefore, my y value will equal to 1 cubed plus half times 1 squared. That gives me 1 plus half. And you can write that as 3 on 2. Okay, so what that tells me is that this coordinate is now at 1, 3 on 2. So that means this y value here is 3 on 2. Great, I've got a coordinate. My job was to find the equation of the tangent line. Okay, I need to find y equals mx plus c. back to year 9 mathematics, there were only two things you needed to find, M and C. We do have a technique in year 11 now to figure out M. And we found out M, like Matt said before, find the derivative. If I want to find M, well, I have a point. The point is when x equals 1. So here I can then write, okay, when x equals to 1, so when x equals to 1, what is M equal to? The derivative is M. So here I sub 1 in, that becomes 3 times 1 squared plus 1, and that gives me 3 plus 1, which is 4. So what that tells me is that this gradient here must now be 4. So we are now almost done. Y equals to 4x plus c. All the way back to year 9 mathematics. I'm almost done. I need to find c. What can I do with the information that's on the page right now to find c? What would you do? Yeah. If I want to find c, if I want to find c, I need an x coordinate and a y coordinate. And that's why it was important to piece things together here. That's the only point on this straight line that I know. On this straight line, I have no other information about this straight line besides the fact that it touches this coordinate. It intersects that coordinate. And that's when x equals 1, y has to be 3 over 2. And I can sub them in. I can say, all right, well, in that case, when x is 1, y is meant to be 3 on 2. So if I put that in, I'm now solving for 3 over 2 is equal to 4 times 1 plus c. To find c, you need to work out what 3 over 2 minus 4 is. And hopefully we can do a bit of mathematics calculation with fractions and negatives here. What's 3 over 2 minus 4? Negative 5 over 2. Very good. Okay, and so what is my answer? To answer the question, the tangent equation should be 4x minus 512. Let's see if this is true. So on your CAS, I'm also going to teach you how to do all of that in one step on your CAS. If you're doing multiplication or the second component, you have to be able to do it on your CAS as well. This is the hand method. That's part of exam 1. Okay, so SAC 1, you don't get a CAS. That's what's expected. The hardest part is depending on what function you get, you have to be able to find the derivative. Hence all those skills that you've been learning, product rule, chain rule, sine, log, cos, tan, all of that is just to get this step. That's why I'm saying you can't derive, that step is gone. When that step is gone, you can't do all this, even though you get what I'm saying. Andre.
How much is that working out with me on the exam?
On the actual exam, this is worth about 2 marks. So they'll probably say derivative, we've got that step. And the next step is to find C. So I reckon 1 mark. It's a 2 marker. The only time it becomes 3 is if this had 2 possible answers. So you can sometimes get not a linear equation. So here we ended up with a linear, but you can end up with a multiple like square root answer, with a square root function here. You end up with 2 possible answers. That means you get 2 possible tangent markers. So for the same point, there could be. So maybe like these 2 points, they can be a parallel tangent gradient. So the same gradients, but different y-intercepts. Yeah, so that could happen. So then that would be a 3 marker. That'd be a 3 marker. All right, here we go. Go over your CAS. If you've got your CAS with you, let's show you how to use your CAS here. So let's visualize what we've been doing. Here we go. I'm just going to go to my menu. Where's my mouse? Here we go. Menu. I'm going to go to graph my picture, what it looks like. So here we go. We had x to the power 3 plus 1 over 2 times x squared. So this is what the graph looks like. Okay. Now, I said that apparently from our calculation, we figured out that 4 times x minus 5 on 2 is meant to touch this curve once. So let's see that. Oh, it does look like it could be. So let's double check. I'm going to go zoom in a bit just so we can see it a bit better. So menu. Where's my mouse? Why isn't it working? Menu 4, zoom box. Here we go. I'm going to go zoom box. And I'm just going to choose a corner. So maybe 1 here and then about there. Let's see. So it's somewhere around here. How do you know if it's true that we calculated it should be 1 and 3/2, right? The intersection should only touch 1 point. So if it's true, if I've done it right, I can go to menu, analyze graph, intersection, and let's see. Let's see if we got it right. So I'm going to the left, click once, move it to the right. It's somewhere between those 2 points. I click again, and look at that. 1 and 1.5, the intersection that they calculated was only 1 point, and it's exactly the point we just figured out. And you can do that for multiple instantaneous points, which is what we call instantaneous gradient or instantaneous rate of change. That's what you're doing there. Okay? But if let's say you didn't want to do all of this step here by hand, can you do that all in one go? Yeah, you can. You can actually just need, all you need is x equals 1, and you only need the function, and it will spit out this answer for you. Okay, so how do you do that? Let's go back to your CAS. I'm going to go back to the calculator page. You can go to menu. Under calculus, there's a term called tangent line, number 9. Okay, so tangent line number 9. Press tangent line, and you literally just type your equation. So your function first, x cubed plus 1/2. Was it x squared? Yep, x squared. And then comma, okay, x equals 1. So what I'm saying there is this, I want you to find the derivative, tangent line of a function of x cubed plus half x squared when x equals 1. And it will do all that calculation we just did for you. So when I press enter, that is the equation of the tangent line. Okay, so this will be useful when you're doing a multiple choice question in the exam also. That's what you're doing. Okay, you can do it by hand, but multiple choice question, you should be able to do most of these questions in 30 seconds. That's the aim. Okay, so hence getting proficient with the options in your calculator, that's another skill. Okay, so that's also a way, as you're doing the exercise, you can check. The other skill, so notice the exercise was called tangent and normal. Tangent is this line here in green. For those who do specialists, or not specialists, it could be in kinematics or physics, you may be familiar with the normal line. Hands up if you do physics or know what the normal line represents. Okay, we got 1. What's the, I'm pretty sure it's called something else in physics. Do you know? I'm pretty sure it's not normal line. It's something, so you get a force and then there's the perpendicular force. I forgot the name for that one. Or is it still normal?
Yeah.
Oh, I thought it was a different name. Anyways, for those who don't know, normal line just means find the perpendicular line. Whoops, let me just draw another color to that. You draw a normal line, that intersects the same point, but we want a line that is perpendicular, meaning it's 90 degrees. Okay, so this is again another y equals mx plus c. If we were to do this by hand, we know that this line still passes the same point. It's still at 1, 3 on 2, but I don't know m and I don't know c yet. But there's one property you learnt in year 9 that you can find m. Anyone remember any properties in year 9 to do with perpendicularity? Good, I'm going to write that down for those who don't know. m1 times m2 is equal to -1. Okay, so what is it trying to say? We already figured out this gradient. We figured out m was 4 before. Yeah? We can use one of the gradients. If you want to find a tangent to it, we know that if you multiply the gradient of this and the gradient of this line and they're perpendicular, it should equal to -1. Okay, so using that property, I can now say, well, since m1, I'm going to call this m1 over here. If this is m1, then I can find m2. I can find m2 by saying m1 times m2, if they're perpendicular, has to equal to -1. So m2 must equal to -1 divided by whatever m1 was. m1 was 4. That means m2 equals -1/4. See that? So that means that orange line now, I know y equals to -1/4 x. I still don't know what c is. This is the only extra small step you take. So you found the tangent line. You want to know the normal line using that property to figure out the gradient of the normal line. Again, how do you find C? I need to find C. What can you do? Yeah, and that's what most students tend to forget. So they can find out M, that's common. Most students forget that the normal line still crosses the same point. That's the only information we have of the orange line, that it crosses through when x is 1, y is 3 on 2. So you can still sub the same point in. Over here, you can still say sub x equals 1 and y is 3 on 2, and you get your equation. So here we go. We do that. This should give you 3 over 2 is equal to negative a quarter times 1 plus c. This is negative a quarter plus c. This is 3 on 2. So to work out c, it must be 3 over 2 plus 1 over 4. Using your fraction skills, what is 3 over 2 plus a quarter? Very good. There we go. You can times the bottom and top by 2, times it by 2, times it by 2. So you get 6 over 4 plus 1 over 4. It just gives you 7 on 4. So what's my equation for that orange line? It must then be negative a quarter x plus 7 on 4. So let's see if this is true. If I type this into that graph before, it should cross only one point, and it should be perpendicular to the line that I had before. So let's see. I'm going to go back to my CAS, go back to this page. Apparently, we know that it is negative 1 over 4x plus 7 on 4. There we go. Look at that. Beautiful. It crosses the intersection. I'm going to go zoom in, zoom 4.2. Let's zoom right in to this point over here. Why isn't it happening? Where is it? There we go. Zoom in, look at that. The black line crosses that point. The red line, which is the tangent line, also crosses that point as well. Okay, it's not magic, it's mathematics, and you are able to calculate, sorry? Doesn't look 90 degrees. Well, oh, did I just move that? Oh no, I just moved it. Whoops. Well, can't ever prove it now, can we? Well, you can technically prove it. Whatever the answer is, it should be the inverse of what you have. So that'll be one way to double check it. But there you go. That's how you do it on your CAS. And actually, you can also find the normal line on your CAS in the same fashion. Menu, calculus number 4. Notice under tangent line, you got normal line. So that means you can do exactly the same as you had typed here. I've just entered it down so I don't have to type it again. And I'm just going to delete this section. And it should be the same thing. Negative a quarter of x, positive 7 on 4. Okay, so you can find the equations with one step. This is for your multiple choice questions. What we've been building up so far is your exam 1 skill. Okay, so you should be able to derive sine, cos, tan, log, exponential, power rule. That's your 6 main ones. Chain rule, product. 8 in total, simply to find m. That's all it is. Every step that you've been doing was just to find the gradient at one point. And that's why it's important, depending on what functions you get. If you can't derive it, this step's gone. That step's gone, everything else is gone. You can't find the normal. You can't substitute to find an x-coordinate. That's why it was important to be able to derive. Okay? So really practice the derivatives. Get really familiar with it. But so far what I've seen, I think chain rule has been good. Practice your product rule. I just made a video for those who are interested in that worksheet I gave. Question 2A. That's a product rule question there. I've got a video link just underneath it for you to watch if you'd like. Okay? But there you go. And apologies, Matt, I haven't done the solutions for the VCAL one, but I will do it while you guys are sort of working as well. Okay?